Hello, I'm Carly McAvoy, and today we're talking about simplifying complex fractions, second part. And this one I have one single fraction divided by another single fraction. But in order for me to work this problem, I need to factor this denominator. The way to rewrite this problem is we multiply by the reciprocal of that fraction in the denominator. So it's going to be dividing by this, but when we divide, we flip it so that the x minus 1 is over x plus 2. So when we divide, we multiply by the reciprocal. And then I'm going to factor this piece. And that is the x squared is going to go to x, and the 2, well, that's a prime number. I can only put 1 and 2. And I need to have this add up to minus 3, so minus 1 and minus 2. If you're having trouble with factoring, I have other videos that can help you with that. And then the x minus 1, because one's on top and one's on the bottom, we can cancel. Because they're exactly alike, I can do that. What that leaves up top is the x, and on the bottom, it leaves x minus 2 and x plus 2. I cannot cancel those x's because you can't take part of a binomial. You can take the whole thing or none of it. So my final answer is x over x minus 2, x plus 2. Okay, let's take a look at this one. I wanted to do this one because the LCD is a little trickier for some people. And so let's look at the number first. The numbers that I have are 3 and 12. This is actually 1. That doesn't change anything, right? So my coefficients are 3 and 12 in the denominator. And so that means that the LCD, number-wise, is going to be 12 because 3 goes into 12 and 12 goes into 12. And then we have to look at the variable part. Remember, each fraction needs to be represented. So this x would say, oh, I need to have an x in there, okay? This one says I need one x, which we have. This one says I need 3 x's. So whoops, we only have 1, so I better make that to the third power. This one needs at least 2. Yes, there's at least 2 there. So everybody's satisfied when I use x to the third. So in general, when you have a variable, use the highest power that you see. The highest power will satisfy all those lower ones. So 12x to the third is our LCD. If I multiply by 12x to the third, then I have 3 goes into 12 4 times. X goes into x to the third. I can take one of those x's and have 2 left. So if you're having trouble seeing that, you can write it off to the side. You have 12x over 1 times 1 over 3x. 3 goes into 12 4 times. That's where I get the 4, right? And what I actually have up here is to the third power. And what I really have, when I write that, I'm going to go ahead and write that as 4. X to the third is x times x times x, right? And then I still have this x that I haven't dealt with down here. Do you see that one of these x's is going to cancel one of those? But that's the reason I have 4x to the second power left. So for that first term, I have 4x to the second power. In my second one, the 12s will cancel. This x is going to cancel one of those x's again, and I'm going to get 3x squared. And it's plus because there was a plus in front of it right here. Then over here, my x to the third is going to cancel this x to the third. And 12 times 2 is 24. Here, x to the second cancels 2 of those, leaving 1 behind, which is going to be 12x. If I could, I would simplify, and I can simplify the top because I have 4x squared plus 3x squared. We know that those are like terms. They have the same variable to the same power. So I can go ahead and add those together, and that's going to give me 7x squared. Now, what about the bottom? Well, I really can't do anything, and for some people, this would be a totally acceptable answer. You could try taking out the common factor of 12, and that would leave you 2 minus x, which kind of is a nice way to state the answer, but it's no different than this. There's nothing that can be canceled, so we're going to call that complete. All right, the last one I just want to do this one because people have trouble with the common denominator, and there's some other little interesting tidbits here. So the least common denominator is what you want to find first. And let me see if I can move my camera a little bit out so I don't have to fight that. Okay, the least common denominator. Well, this denominator wants an x plus h, so I have to put that in there. This denominator wants a standalone x. This x is attached to 8. That's a different thing. So this x is different than the x plus h. X plus h comes together. So if you have an x or an h alone, it doesn't count. This one, though, is actually over 1, right? So that doesn't affect the denominator at all. So my LCD is x times x plus h. But I have to do that in the numerator as well as the denominator, even though this one didn't have a denominator as part of it. So when I multiply, this x plus h on the top is going to subtract or cancel that x plus h on the bottom. I'm going to be left with that x though. Then I have a minus, and then I'm canceling the x. Notice I'm left with x plus h in parentheses. That's important because I'm going to distribute that negative all the way through there. Down here, I'm just going to get xh, x plus h. I'm just multiplying all that together. What am I going to get on the top? Well, I'm going to get x minus h, and then xh, x plus h. The x minus x, those are opposites or additive inverses. They go away. And so I get negative h over xh, x plus h. And what's going to happen here is that this h is going to cancel that h. But remember, when you cancel something, it doesn't become 0, it becomes 1. So this is 1 too, but 1 times x is just x. So my final answer is going to be negative 1 on the top, and then x times x plus h on the bottom. I don't need to show that 1 times x because 1 times x is just x. Okay, that's my second video, part 2 on simplifying complex fractions. Have a fantastic